Hey, a very good afternoon to all of you, and welcome to this session on data science. We are going to spend the hour really getting a good understanding on the field of data science. The best way, of course, to do is look at business use cases, case studies, how is it being applied, where is it heading, and then move on to the next question where a lot of us as aspiring data scientists, when you all start to read around and you see so many technologies at play and you wonder where should you begin, how do you build your skills, and that is where we're really going to wrap up. We are going to spend about 40-45 minutes doing so, and after that we are going to take all your question answers. So what I would ask you to do is listen in, pay attention, consume, and then frame your questions so that you're articulating them based on all the information you have, because that will help uh, you receive more contextual answers, and it will help me provide much better answers. And I will make sure that I take all your answers before I close, so don't worry about it, right? So as we are set to begin, let me just do a quick um, audio video check again. So I would like you to use the hand button. If you can just use the hand button on the panel to indicate you can hear me absolutely okay. Okay, I see a few hands go up. Okay, I see more of them go up. Okay, that is good. You can put your hands down. Thank you so much. So let me start with my own introduction. My name is Shweta Gupta and I'm responsible for the data science education at Digital Vidya. In terms of my experience and profile, I am a technologist. In my 20 years of career, of which most of which was at IBM, 14 years, yeah, I've done pretty much everything. Started coding with C, C++, then I moved on to J2E technologies. I did domain wise, I was with collaboration, I was with the distributed computing, and then eventually in my career I was doing e-commerce consulting before I hopped on to the bus of data science. Now with this experience, what I definitely know is two key things. One is when anybody is looking to build new skills, because I've done that several times, what it takes, right? What is the kind of passion one has to bring in, uh, and how do you spend, those a year or so just kind of really learning, applying before you start to move in with the experts, right? So there is that time, and having done that several times, I can definitely walk that path with any of you who's willing to do it. The second key thing is, having worked with very large implementations, especially in my span at IBM, bringing the right skill in from the client, how critical it is, and what it takes to translate business goals, business problems into solutions. Because eventually, when we're looking to work with data, what is it that we are doing is we are really trying to figure out what does this data mean for the business, right? And business can be a social cause, it can be government data, it can be very hardcore BFSI data, manufacturing, right? Pretty anything. But the fact is that there's so much data sitting there, and why is it all, if there's one question which is throbbing many of you, is that, of all the years, why in this decade, why is the field of data science so relevant, right? It is because of three areas, right? Three reasons. One is the amount of information which we are generating now, right? The internet 2.0 happened, then the social media happened, and then the internet of things is happening, right? All this, we are generating a lot more data than we've ever done before, right? So data is one very critical part. Now the second important part is, since the advent of computers, computer engineering, all the researchers actually thought that computers are going to be like human, right? They're going to be artificially intelligent. However, it turned out for a long time we have been doing very, very instructional programming. Feed something in, um, they will exactly do the same thing and give an outcome. Uh, with artificial intelligence, machine learning algorithms coming up, this is helping to solve problems which we could never do before, right? And we are going to look at some of those examples. The third thing is, of course, the storage and the processing power, or make it 3 and 4. Because for some of these complex problems, unlike for us human, where we can just look at an image and do a lot of things, computing and to be accurately able to do it, it needs to process a lot of data and do it at very good speed. So with all these aspects coming up together, it's really this decade which is going to solve a lot of problems. So if we look at, let's kind of pause and let's look back at the industry of data analytics, because people have been doing analysis for a while now, right? For a long while. The focus there has been exploring data to understand the underlying patterns. Now, based on the patterns, you bring out certain insights that help form the basis of actions for the business. And the value it gives back to the business is really the cycle of data analytics. And to simplify it, if you were to look at, if most of us are using some kind of credit card or payment card, if you just look at a credit card company and, month after month or quarter after quarter, it is trying to reach out and expand its business. So what it means, it really needs to identify its customer base. And if it needs to know what are those customers it should target, so it will do some kind of categorization. Who are my high risk customers? Who are my medium risk but big paying, right? Who are my really low risk customers, but they also don't give me much money, right? So this kind of categorization they'll be able to do by crunching data and really following this life cycle, and then giving it out, giving that recommendation out to the marketing folks, to the sales folks, who will then be able to put in the right promotion to target them and then bring in business. And this is the kind of case study you would actually do as part of skilling. Right? So data science landscape, I have already covered a few terminologies, but let me just do it for you. I just want to do a hand show again. So, every time when you're done with it, you can put your hands down so that we know you're answering to the newest question. How many of you are already familiar with these words, machine learning, deep learning? And not only familiar, you really understand how does it differentiate? Okay, so fair enough. I think this is the right audience, because this is where I'm going to be introducing you with it. So if you look at the field of data science, we talked about analytics, we talked about that is really, really covering whole lot of statistics. Okay, before I move on, I see a question where somebody said, somebody is asking me, I don't see the name, ma'am, once more insights explained. Okay, so I'm coming back to this. So when we say insight, what it really means is that based on the data, so using the example of credit card, as I was saying, based on the analysis which we do from the customer data, say if the data tells us that specifically customers who are in their early income ranges, that is 21 to 25 years of age, they are doing extremely high expense and they are not even making full payments, and they are doing therefore they are having to pay certain level amount of interest. I'm using a very simplified example, but based on the analysis, this is the insight one will draw. And now based on that insight, one can make prescription that to the marketing team that therefore now reach out to this customer in this way. right? So what is a prescription? I just use another word. So it's just like when we visit a doctor, and based on the diagnosis, they would actually prescribe, right? Prescribe, take XYZ medication to recover back to your health. So a prescription is a list of things which you do. Okay, moving on. Now, in terms of terminologies, as I was using this example of credit card, it was really analytics which was firmly based on core statistics, right? So now don't worry, I'm going to use the word statistics a lot, but don't get thrown off, because as part of skilling up, statistics is very, very critical, right? Most of us, when we were doing undergrad or +2, right, in school or undergraduation, we may have had done some courses in statistics, but we probably didn't take it serious enough until we were in the applied sciences of stats, right? For rest of us, it was probably some reasonable level of theory and interest, and we've forgotten about it. But now that when we are ready to work back with data, statistics is a very, very key foundation. Now, what does it mean? To be able to understand what is the kind of sample population we have, what is the kind of distribution of data, is it skewed, what is the kind of summary it presents to us, what kind of hypothesis we are going to build, just understanding of the business problem, what kind of data it is showing up to be, right? What kind of regression, what kind of slope. So whole lot of stuff is all statistical in nature. And that does form the foundation of data. Now, as I said, the next thing about this entire domain of artificial intelligence is when we are trying to solve these business problems, right, using applied statistics, but in such a way that our algorithms and machines are learning. Okay? These algorithms which are learning are called machine learning algorithms. So what they do, they learn from a given set of data. So a data which will say that, these are the 10 attributes of a customer. And based on this, we classify this customer to be of medium risk. And if you give this algorithm 10,000 such information, it will learn from it, and then you test it on another 5,000, right? You have trained it, now you test it on another 5,000, and then you see how accurate is it giving this classification, right? And then you work on increasing the accuracy of this algorithm. So this entire working is machine learning. And a very, very key niche of machine learning, which is very, very relevant today in advanced problems of deep learning, of data science, is deep learning. So deep learning is basically what brings closest to the way humans work, because deep learning is based on neural networks. So suddenly some things which were taking a long, long time to compute and work out, using neural network, we are able to do that calculation really quickly, right? Whether it is using back propagation or numerous other things, it really, really helps us to get to that solution really fast and increasing the efficiency of the algorithm. Right, so don't worry. I think for you to understand terminologies in just right level at this way is enough for you, right? As far as you understand that this is the different things which are being done in data science. So let's look at a few examples where you see yourself as consumers of data science. So the moment we Google, every time we Google, you'll see as we start typing in the text box, Google will predict for you that what are you going to type, what are you going to search for, right? It is going to predict. Now, when it's trying to predict, what basically it means, based on the data it has trained on, its algorithm is able to throw in the predictions of various statements complete. Another area, e-commerce, right? Every time we are shopping, whether you are on Amazon, Flipkart, or you're doing stream media streaming on Netflix, right? Pretty much everybody. In fact, Netflix is somebody who, over a decade back, they ran their first competition, and they asked the machine learning data scientists to help them improve the accuracy of their recommendation engine. And what it meant was, how do you measure your accuracy of recommendation engine? Basically, it means while you're browsing in Netflix, right? You'll probably look in and search some things which are familiar to you, but Netflix is able to show certain kind of items to you which you probably won't have clicked otherwise, right? It surfaces them for you, and then you click on it, and there's likelihood that you get really addicted to it, and you end up watching the entire stream. So the measurement of how it is being able to surface out those actions which you are likely to start watching, right? That's a big way of measuring the algorithm. And it ran its competition over a decade back to help use a real large crowd to improve their accuracy. And pretty much every e-commerce engine uses different level of recommendation algorithms to suggest to you whether it is inspired by everybody's shopping trend, collective, yours, your viewing, your browsing, your purchases, right? So it tries, whole lot of combination it does. Moving to the next example, which is slightly varied but very interesting, is what a new age word is Internet of Things. But if you look at the airplane industry, right, it's been using this forever now, to an extent that now if you see a typical flight, it involves very limited, and one of the New York Times reports said that only 7 minutes of human stirred flight, which is typically reserved only for takeoff and landing. So basically, rest of the navigation based on the based on the machine, based on the algorithm, based on the environment, based on the data it has it current, it is able to navigate successfully. Photo tagging. Now this has taken a while for people to get right. So when Facebook started, because for humans to be able to look at a face and immediately do that pattern matching versus for an algorithm to be able to identify the faces in the picture and then match it to what it knows is existing is one of the complex problems, which now with the advent of deep learning are being able to be really making progress. So this is one example of that. Moving to some other more complex applications. So if you look at the sports teams, they've really been doing, there's a lot of money on it, there's a lot of analysis that goes on, they're huge teams, especially if you look at football. If you look at FIFA, there are articles about how it is using an analytics algorithm to do very detailed analysis on how the team behavior is during the matches, how the passes are being done, what is the distance, and whole lot of analysis, which otherwise how they would sit down, watch a full video play and then do certain level of analysis. But here now an algorithm is sitting up, doing whole lot of analysis for them and just putting it up in charts, right? And then coaches and trainers, they can use that data to really discuss it and make a much more profound points and enable them to debate more accurately and identify fitment of players, fitment of teaming, etc. Of course, any team games are much more complex, because if you looked at this year's FIFA, and I'm sure you all would have realized that till the playoffs didn't happen, nobody predicted actually who's going to make it to the final. Nobody predicted these two teams, right? It just didn't happen. And the reason is because when you have this multiplayer game going on, there's so many other aspects to it than a prediction algorithm, which would eventually depend upon, it takes care of a lot of errors, it uses multiple variates, but still, if its basic assumptions start to go wrong, it goes all the way, right? It really fluffs and fails all the way, which happened this year. Jumping to another example, Instagram. So Instagram, there's a bullying survey, right? Trust me. So one of these annual bullying surveys, it said that 42% of UK youth reported Instagram was the most bullied platform, right? This is where the youth was being most bullied. As an outcome, Instagram, before other older social media players, Instagram became the first one to use machine learning to be able to identify offensive posts and take action against it. Of course, there's level of complexity, level of accuracy, there's more work need to be done. However, it did receive praise from Cyberbully Prevention Organization for this work, and it has been, it has to continuously do work because natural language programming is one of the most complex things for a machine to work on. And that brings us to natural language processing. So if you look at any business, today as you're browsing, everywhere you see chat box coming up and talking to you. There were virtual digital assistants, artificial intelligent agents, because every business is eventually interacting with customers who interact in natural language. So whatever work which gets done in this area really can impact from very small businesses to medium to large to everybody, because just imagine the kind of efficiency one can bring in by not having to put humans just to do the basic level of conversation or a reasonable medium to advanced level of troubleshooting. But it is complex, and that complexity got demonstrated when this year Google did its demo of artificial intelligent agent. It was in May. It was called Google Duplex. So let me see another hand raise. I want to see how many of you watched the demo which Sundar Pichai made this May. How many of you did that? Okay, I see a few hands going up. Okay, that's very little. So let's do a refresh for those who have seen it, and for rest of you, watch it. It's really, really interesting. So I'm going to play it.
As I said earlier, our vision for our assistant is to help you get things done. It turns out a big part of getting things done is making a phone call. You may want to get an oil change schedule, maybe call a plumber in the middle of the week, or even schedule a haircut appointment. We're working hard to help users through those moments. We want to connect users to businesses in a good way. Businesses actually rely a lot on this, but even in the US, 60% of small businesses don't have an online booking system set up. We think AI can help with this problem. So let's go back to this example. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
Right. So another question for all of you. How many of you could not really distinguish between the artificial intelligence agent and the human in this conversation? How many of you could not distinguish it? Can I see some hands if you could not distinguish a single knot that was. Okay, that's interesting. So rest of you could do that. Uh, but what was the most interesting part about this conversation? It was the fact that the machine was exactly conversing with the ease, with the annotation, the it did. This was completely a game changer because we have only been seeing the robots talking to us like this in our sci-fi movies. It has not cut it and made it to the ground. And even if you see this announcement, even this agent will not be able to make very generic conversations. It is meant, it is directed, and it is trained to make very specifically certain kind of a points. So that means even this space, even today, it's in a trajectory where there's a lot of work to be done. And many of you who are really interested in this field will see yourself being part of this journey. Okay, now moving from these examples, I think the next question, which typically everybody has as you start reading, is what is this, different so many technologies and what you should be doing? Why are there so many different technologies? What really means? So there are a lot more than what is shown on this chart, but this will give you a fair, good understanding on some of the most, verbose, obvious ones. I'm going to do a little storytelling on this chart, and if you all pay good attention, this will become really clear to you, right? And it will solve and address the question which you may have in your mind, right? So I want you to pay special attention. So bear with me, because I want to start with understanding the profile of today's audience. So there is a poll coming up on the screen, and you'll know why I'm doing this. So there's a quick question coming up asking what best describes you academically or professionally as of today. So it's a very simple to understand how do you identify yourself as today. So if you can just help me know, choose the first one if you're anywhere from the IT field. If you're not from the IT field, you're from HR, you're from any other function, choose the second option. If you're a student, the last two options are for you, right? So even if you don't see your precise title up there, don't worry. If you identify yourself as somebody from the IT industry, choose the first one. If you see yourself from a functional role, choose the second one, right? That's the guideline I would want you to use. You don't need to overthink this. This data is just to help me understand what is the kind of weightage I give as I explain to this chart. Okay, I see a few sleepy folks on the call who are taking a little bit of time. So let me do a quick down. 5, 4, 3, and I'm ready to close the vote. So thank you for those who let me know about yourself. Okay. Wow, that's a pretty interesting data I have today. It's extremely skewed towards students. I have 45% students from com science background. Then I have 30% people, 29, who are from IT. And I have a much smaller percentage, just 14% from functional backgrounds. That's really tiny, along with 7% who are pursuing some level of education in the non-IT fields. So folks, even though you're in a smaller number here, let me start addressing you all first, right? So people who have the data with you, are going to be working in roles which are going to have data in you. When I say when you have data with you, what does it mean? So what it means is that when you are somebody who is into sales, that means you're making the sales, you know your customers, you know your products, so right, you really own your data. Or you are in HR, you like pretty much know your entire organization, right? You're doing trading, you're doing finance. There's just so much information which you are receiving in day in, day out. You're a marketer, whether a digital marketer or offline, whatever you're doing, you own your data. And the amount of data you have, it's all over different places, different channels, and you're making decisions. If you are making data-based decisions, you're really being effective in whatever you're doing. Otherwise, it's really garbage sitting there. And that is the reason it is very critical to understand, as somebody who is functional in their roles, how to make data-based decisions. And that is this very one technology on this chart, which is extremely powerful, along with a few other things, of course, and that is none other than Microsoft Excel. If you look at one of the surveys which was published by O'Reilly, so O'Reilly is a technology publishing firm, and many of you may not know of it, people who are from non-IT. You can just search it up. If you Google up or O'Reilly Data Science Survey, you will find the results. This was published just last year, very recent report, 2017. The survey was targeted towards the European data scientists, and the question to them was, there were several different questions on, what do you do, what kind of problems you solve, what kind of field are you in, what kind of tools do you use. And this specific question, if you look at the response, 69%, can you see the biggest bubble up there, right? The biggest bubble here, this one. Oops, sorry. This biggest bubble, 69% people said that they use Excel for their business intelligent work. Okay. So that's pretty solid, and that is extremely accurate. Because whether you are in running a home or running a company from home, from your garage, you're part of a small company, a medium company, a large company, or a very large company. Your, your data may be sitting up in the most complex ERP systems, Salesforce, databases, but eventually what people do, they're going to pull their data into a spreadsheet and do some solid analysis and make decisions. So that is one technology, extremely free, right? Rest, all the technologies on this page is really for people who are mostly working with other people's data. So let's go back and start with the history. Let's look at SAS, right? Now SAS, 1960s, a long way back. Now, mind you, the programmers here of the new age, this is not software as a service. This is not that SAS, not with the double A. This is statistical analysis software, SAS. Now, I'm going to reiterate to you that statistics is the foundation for data science. Right from the early 1900s, it was the statisticians, and one which made really big gains and did a lot of white papers and intellectual property is a statistician called Gosset, who was working with one of these wine companies in North America, and who had to identify which kind of barley, what kind of production will yield to the best wines. And a lot of work continued in agriculture, in fact, for as part of a statistician's work. And as the computers were in action, statisticians wanted to leverage it for the computing, and they got together and they formed a software, and it got incorporated into company. And SAS in the same league as, say, SAP ERP implementation. What it means is that only the largest of organizations are going to use it and deploy it. Right? It is expensive. It is maintained software. It is, its entire data security is very strong. What it means is that even today, the banking, finance industries, healthcare industries, they do have SAS, and they're using it at least for their most traditional and legacy analytics. For a lot of new work, they have moved on. They are using more technologies, but SAS does stand to be one of these, really solid loggerheads for the largest companies. Now, towards the end of 1900s, the statisticians who were working with the academy or with the smaller firms, they wanted some computing, and SAS was, kind of too expensive for them. They were not going to get those licenses. So they came together, again, statisticians. They came together and they created an open source tool, and they just simply called it R. So remember, R is not something which is a programming language which does, a lot of other work and web development. No, it does not. R was created purely to do statistical functions in machine learning, and because of its niche, it became the primary language of use for data scientists, and it really, really stayed at the head of this work for about last 15 years, up to last 2 to 3 years. It was right up there. Now, what started to change was a lot of software engineering companies coming up, taking up data science and artificial intelligence and stuff. And now, because a lot of software engineers came into way, it was obvious that people needed some programming language which was easier for the software industry. And in the meanwhile, some of these, because Python is also open source, a few folks came together. They started to create statistical libraries, NumPy, SciPy, this, to work with data, pandas, and then these machine learning libraries like scikit-learn. All this started to make Python a pretty reasonably good used library. But what changed? The entire thing was in the last 2 years, all the new work which happened around the area of deep learning, that completely happened in Python. And what really, the to the level it changed it now, if you ask the data scientist community in the world, which was done by Kaggle in its survey in 2017. So let me just quickly check how many of you are familiar with Kaggle. So if you can put your hands down and then raise them again. How many of you are familiar with Kaggle as a data science platform? Okay. So for those who don't know yet, go ahead and browse it. So Kaggle is an open source platform where data scientists come together collaboratively. They write code to solve problems. Companies come in and they host competitions so that they can get their complex problems solved by this very, very smart scientists, wherever they may be, and they actually give out prize money to them. So it's an extremely interesting new age platform for data scientists. And last year, in the survey, they asked several questions to the data scientists. Again, you can go read up the survey, it's available there. And the key question which all of you as aspiring data scientists have, the question was formed to them: what language would you recommend new data scientists learn first? And the very, very clear answer they gave is Python. Right? Now, if we look at the last topmost things, those are part of the big data landscape, a few of them, but overall big data landscape, which is Hadoop, Hive, Big, Apache Spark for real-time analysis, whole lot of stuff. But what you have to understand is big data is a set of technologies, right? But the science of it is data science, is statistics, is machine learning. So remember, you must focus on building your data science foundation and concept before you become too much into just using tools. Right? So it is better to use a strong programming language so that you learn the fundamentals of data science well before you expand on. So that is the whole story on technology landscape. I did promise I'm going to spend a good amount of time, but with this, I really, really hope you have simplified for yourself these different technologies. How did they evolve? What is it most relevant today? Why did it change? I hope you got a whole lot of that. Now with that, let's kind of try to summarize What are those skills there for? If you want to build as aspiring data scientists, if you want to build skills, what you should be doing. So really based on this Venn diagram, which was created a few years back now, but it's very relevant because it really talks about three key skills, right? One is statistics, which I have hopefully enough times reiterated and reinforced to all of you. The second key aspect is the tool. So one will need to use one at least tool and become really good at it. And then the domain knowledge, because there's no way to really solve those business problems if you do not know the business of it. So these are the accumulation of skills that you require to be a good data analyst and data scientist, which is really, really the difference. One question everybody wants to know: data analyst, data scientist. So the industry has kind of been changing its meaning, but primarily how it uses it, the data scientists are more focused on machine learning algorithms. But rest of all the work, the statistics, the data pattern recognition, the all the application of statistics is done by data analysts also. But the machine learning algorithm part, deep learning, programmatically, a whole lot of work which is done makes up more specifically data scientists. Right. So I'm going to wrap up the session in the next 5 minutes so you all can start to then type your questions, and we will move on to the question answer round as I had promised, and I'm going to give it enough attention. Before that, I'm going to address some of the common questions. One question which people always have is, based on my current profile, what should I do? So it's a very clear distinction. If you are in a functional role, now what does it mean by functional role? Again, it's a repeat. It is a role in which you have the data and you're not really looking only to work on other people's data, right? You're not looking to become a programmer or a data, looking to do very deep learning algorithms, but you have your function. You're a sales, a marketer, finance, HR, operations, logistics, customer check care, supply chain, inventory management. You do n number of jobs. You do something where your objective is to help your business, help yourself make database decisions. So that is what is a set of curated skills which you can really, really use to do this very well. The second set of people is people who are typically programmers from IT background who are looking to solve problems for their clients. Your objective is to build a career in data science, work with machine learning algorithms, move towards the aspect more advanced artificial intelligence, and that is where you really pick up a programming based learning. Next question which people have: I'm a non-programmer but I want to get into data science, what should I do? Answer is, remove the non-programmer tag. Even if you have been out of programming practice for over 2 years, it is your responsibility first to remove that tag. The first thing you should do is make yourself comfortable in programming. The only reason is that when you learn data science, your focus should be on data science and not on learning programming, right? That is why it is very, very critical. As Digital Vidya, what we are a very simply to learn course called Python Programming Basics. It is self-paced, Jupyter Notebook-based tutorials, so that you open Jupyter Notebook is a very simple way. It's a coding environment which allows you to code, make your comments, see the output all in one. So using this, if you give yourself, 3 to 4 weeks, and if you do it, you're ready, right? That means that you are absolutely comfortable with your basic Python programming. Once you're done, then you have done away with that non-programmer tag, and you are ready to pursue a more machine learning programming based career. So the two courses which are curated for our people who do functional roles, we call that course Analytic Techniques Using Excel and Power BI, What we cover, we start you with very basic Excel, we take you to very advanced Excel so that you can do a whole lot of work with the data you have. You have a statistics refresher, you have SQL foundation so that you're confident working with data, especially if it sits around different databases, and Power BI, which is a visualization tool with Microsoft, which allows you to do a very strong storytelling. You become an IPL statistician by the end of it, because that's the capstone project, or you do the credit card risk assessment, the example which I've been using throughout today's course. And this is an instructor-led live course. And the other course for programmers is data science using Python, in which you learn all aspects of working with data and till you build your machine learning algorithms, and you have learned how to work on the accuracy of the algorithm. You have natural language processing based project, healthcare project. The strong thing when you come and work with Digital Vidya is, one thing you have to remember, at the core of data is being able to work with data. Like I would say, if you're learning to play a sport or an instrument, so for example, you decide you're going to learn to play piano, and you sit down, every week you watch some 3 to 4 hours of video. What at the end of 10 weeks would you say you're a pianist? No, right? I mean, you have to be playing piano before you start to make any claim about being a pianist. So it's very critical that we see you all learn to work with data in the right way. So our focus is that as you do your 3 hours of instructor-led learning, you learn capture a lot of concepts, do some hands-on, but eventually you must spend at least 5 to 8 to 10 hours in the week refreshing your concepts and doing assignments. That's extremely key to us, right? Our learning management course, it allows you access lifetime, you get to see refreshes, you get to participate in internal competitions, which really helps you to sharpen what you have learned. It's extremely exciting. The question answer forum, it helps you to collaboratively learn just the right way, which you should be doing in today's world, or you would be doing in an actual project environment. We have a placement team, and all of it together, the focus really is to enable you to build skills the right way. These are the upcoming course dates. We actually have bundled master programs, and the Python programming course and statistics foundation is available for free. Any of you who want to start brushing up, you can start today. Just talk to our consultant and you can start today. Okay, so I'm going to jump into question and answer. And at the same time, I'm going to bring you up one quick poll where I want to know, based on the information so far, what data science specialization are you looking to do? So if you can quickly respond to this poll, and I'm going to start reading the questions and start responding to them. So feel free to start articulating them. Okay, so Sai, you wrote, can you please increase the volume? I think that was when I was playing the Sundar Pichai video. If you were not able to hear it, please just Google on Google Duplex and do listen to that video. You will find it extremely interesting based on the kind of work natural language processing has to go through before this field is really done and dusted. Amreen has a next question. Without statistics background, is it possible to learn data science? So when you ask the question without background, you mean till today you did not know statistics? Is it possible to learn and learn data science? The answer is yes, but you have to learn statistics. So right today, you start refreshing your statistics. You have put together Statistics Fundamental 101, which will help you refresh them. And there are small topic coverage, so you can keep refreshing and revising and keep doing that. But do not try to become a data scientist without statistics, because that's really bluffing, right? So you must make sure that from today you start grooming yourself to be a statistician. You don't have to remember those equations, you don't have to solve them physically, but you must know your concepts very clearly, Amreen. I hope I answered that question clearly. Next question is from Achint, Achint asks, is Excel plus Power BI program besides the capstone projects, will there be intermediate dummy data tables exercises to learn? Achint, absolutely. Every week, as you learn the concepts, you get to do an assignment so that you can apply those concepts which you have learned. Because as I explained to you, just like piano, just like learning to play football, you cannot learn data without solving. So absolutely, Achint. Next question is from Menk. How much time does it take to be good in statistics? Menk, I would say it would take a lot of time. It would take years. So start today. Don't waste your time. The key thing is how much time will it take for you to get your basics right? Right? If you start reading today all your topics and start refreshing them, I think in 4 weeks you would feel pretty confident about your probability, about your distribution, about linear regression, about calculating, mean squared value, about identifying errors. So you would be pretty good in it, and you would know your fundamentals. But you'll have to give yourself at least a year's time before you can really start calling yourself an expert in anywhere. Kiran's next question, should I learn all three languages, that is Python, R, and SAS? Kiran, no, please don't do that. Your focus should be on learning data science using one language. And that language, let it be Python, because the industry is using that the most. It's most likely you will do your projects in that. So start with that. Down the line, if you feel you must pick up another language, in our, we have created a bundle which is data science using R. We have provided it as a self-paced, and once you know data science, you will just be able to learn it yourself. But do not jump into it parallelly. Get your data science, your statistics really sound. Just focus on using it one language so that you don't get carried away by languages, but you get really solid in data science. Kiran, I hope that I clarified that question. I am waiting for the next answer. In the meanwhile, people who have not yet responded to the poll on the screen, please do that. Of course, if you're still typing your question, that's fine. You can wait for it. Next question is from Sarthak. What is the salary bracket of someone who has been working as a data scientist for 5 to 10 years in India? Sarthak, I avoid answering sorry, I avoid answering questions on salary. The reason is, even though companies, who are looking for talent will put out what is a typical salary they offer, but there is no way to know once the actual placement has happened. As somebody working with data, I would not talk about stuff where the data is not even available, right, to me. What I would ask you to do is look at portals like PayScale, where as a business, they are determined to collect accurate data. And that is a place where you'll find the most relevant and correct data. I'm not the right person to give that or share that data. Anupam asks how difficult it is to break in data science for a non-programmer with data analytic experience only in Excel. Anupam, the answer to this question is very simple. If you give yourself 4 to 6 weeks, and if your programming is really become very clear, then doing data science just as a programmer would do, there will be no differentiation. Let me answer this question to you in another way. If you look at all the IT industries, when they come into campus recruitment, they don't only hire computer science graduates. They go into ENC, electronics, electrical, mechanical, they go all over. Because programming is something which one knows. Somebody who's analytical and logical can pick up programming language in a given length of time, right? So it's not about difficulty, it is about personal interest. And the best way to answer that is for yourself. And that is why we have the Python Basics programming course. You go there, start doing it today, spend a few weeks on it, and you will know yourself how comfortable you are with programming. Anupam, I know you are asking with 14 years of experience how much more difficult it is. I know of both ways people who are from completely different background, pharma, medical, and at some point they picked up programming and they became programmers, and then they started to do other stuff. And I know a lot of programmers, core computer scientists, who stopped programming and took up different roles. They went into project management, or they went into testing, which did not require them to do programming. So they're all kind of people. So as that's why I said it is for you to decide. Anupam. Sai has a question. What kind of career opportunities do we get after learning these skills? So Sai, typically what happens is companies. So let's look at it, right? People who are, say, heading a sales division or marketing division, right? They are looking to become efficient, expand their business, expand the profitability or the bottom line, and that is why they need smart people who can work with data. They can call them business analysts or data analysts, but they need people to work with data. So these are the roles one would get. The other kind of role is when a company like Flipkart is trying to build a recommendation engine or is trying to solve a supply chain problem, and it puts together a data science team to do its work. Now, what is a typical data science team going to constitute of? It's going to constitute of somebody who understands the business so that they can translate business into this. It's going to have a very senior data scientist who has the experience, understands which algorithms to apply where, what kind of problem to solve. And then there's going to be set of 4, 5, 8 to 10 team members, data scientists who are going to be, junior data scientists, mid-level data scientists, senior data scientists who are actually going to implement the algorithm, train the algorithm, test the algorithm. There's going to be people who are going to deploy it into production. So any of these rules can fit people who do data science. Of course, one will have to start with early career data scientists. Bank has the next question. Comparing it with business analyst, are data scientists less required in job market at present? What would be future scenario in 5 to 10 years, especially in India? Bank, every report by the research companies, whether it is McKinsey, whether it is Gartner or Forbes, everybody's been saying that no business is going to be able to survive, stay competitive, be profitable until they are making database decisions. Now, what it means is every company has already started to put some level of data analysts of all sorts in their company. And data is going to continue to grow, it's going to change, so this work is not going to stop. The relevance of data, the importance of data is going to continue. So the next decade is going to see a lot of requirement. Okay, I'm waiting for the next question to come out. So continuing to answer your question, man, comparing it with business analysts, are data scientists less required? That's an interesting way to ask question, but let me explain it this way. Business analysts are people who are needed in every function of the business, wherever data is. However, data scientists are going to be focused on solving. There's more fund to solve the problem because you need to set up a team of 10 people who need to work for 6 to 8 months or a year to specifically solve one problem, right? Or spend 2 years solving one problem. So, there's going to be a need for both kind of people, but data scientists are going to be solving very, very complex problems or problems where there's fund, where a business analyst has to be there in every function. Anupam's next question, how to make the choice of learning either Python or SAS or maybe RAR? You mean R. Anupam, I really tried to solve that for you when I went through this chart. I'm not sure how much attention you paid to it, but let me make it really easy for you. This question, what language would you recommend new data scientists learn first, was asked in the Kaggle survey. 16,000 data scientists replied to you. So you can decide whether you use their consensus or you want to use some other methods to make your decision. There is data out there. I'm showing you the data. You take your decision. Okay. Next question from Sai. I'm undergraduate from NIT Calicut. I worked with NumPy and data visualization. Quite comfortable. Can you suggest any other courses to do along with this to excel in data science field? Sai, you don't need to do courses anymore. What you can do is go to Kaggle and do a lot of practice, participate in competitions, participate in hackathons in India. That is the way to build your profile. You should focus on building your profile. I don't know how much machine learning you have done because you have not talked about it, because if you have just worked with NumPy and data visualization, you still need to learn your machine learning. But really to practice Kaggle, I mean, that's the best place. There's so much amazing work up there that you can learn, you can contribute and participate in competitions. Okay. That's the way to excel. That's the only way to excel. Practice, 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 participate. Okay, so looks like we are at the end of our question. So I will close the session. Thank you so much for your participation, and I wish each of you all the very best. If you have further questions, please talk to a consultant or to email me at shweta.gupta@digitalvidya.com. shweta.gupta@digitalvidya.com. I have pasted it on the text. Bye-bye.